It's the beginning of July. The hottest day of the year so far was about a week ago. It saw 500,000 people descending on beaches in Bournemouth. It's more of a typical British summertime at the moment. Camping weather, I call it, after many a long year under canvas listening to the soft patter of cold rain. There's lots of talk at the moment about global warming and climate change and a call to action. Recently, the government declared a climate emergency. We had the spectacle of Extinction Rebellion gluing themselves to tube trains. What I'd like to do today is to take a look at the science behind the headlines. I'd like to look at global dimming and the greenhouse effect. Once we've done that, maybe then we can go save the world. Earthrise is a photograph of Earth and some of the Moon's surface that was taken from a lunar orbit by astronaut William Anders on December 24th, 1968 during the Apollo 8 mission. It remains one of the most famous photographs ever taken. It was the first time that people had seen the Earth in quite this way, and it changed the way people thought about it. The 1960s marked the beginning of the environmental movement, which is now more important than ever. At this time, when people asked themselves what the probable consequences of man's activity with respect to the environment might be, there was a theory called global dimming. Burning fossil fuels could lead to a build-up of soot and pollutants in the air, which could mean less sunlight got through to the Earth, resulting in the Earth becoming cooler. There were concerns that the Earth was heading towards a new ice age. It was the time of the Cold War, and Warsaw Pact and NATO forces faced off across the Iron Curtain with enough nuclear missiles to destroy the world 20,000 times over. If the 4-minute warning sounded, that was how long you had to live. It was MAD. MAD stood for mutually assured destruction. Honestly, people were more concerned about that. Global dimming was a well-established idea. The year 1816 is known as the year without a summer because of severe climate abnormalities that caused average global temperatures to decrease by 0.4 to 0.7 degrees centigrade. Summer temperatures in Europe were the coldest on record between the years of 1766 and 2000. This resulted in major food shortages across the Northern Hemisphere. It was also the year Mary Shelley wrote the book Frankenstein. She was on holiday, and there was absolutely nothing that they could do, so she stayed indoors and wrote that novel. Evidence suggests that the anomaly was predominantly a volcanic winter event caused by the massive 1815 eruption of Mount Tambora in April in Indonesia. This eruption was the largest in at least 1,300 years. 160 million years ago, scientists believe a huge meteorite struck the Earth. It threw up a huge cloud of dust that blocked off the sun for years. Everything got much colder, plants could not photosynthesize, and almost everything eventually died. It marked the end of the Jurassic period. The dinosaurs which had ruled the Earth for 100 million years were gone. The path was clear for humans to evolve and take their place. Global dimming is the reduction in the amount of global radiance at the Earth's surface that has been observed since measurements began in the 1950s. The effect varies by location, but worldwide it has been estimated to be of the order of 4 to 20% reduction. Global dimming is thought to have been caused by an increase in particulates or aerosols, such as sulfate aerosols in the atmosphere due to human action. Obviously, it can also be caused by volcanoes. Global dimming has been attributed as the leading factor in the 1984 Ethiopian famine by reducing heating at the tropics, which drives the annual monsoon or wet season. The Indian Ocean brown cloud or Asian brown cloud is a layer of air pollution that currently covers parts of South Asia, namely the northern Indian Ocean, India and Pakistan. Viewed from satellite photos, the cloud appears as a giant brown stain hanging in the ocean over much of South Asia and the Indian Ocean every year between January and March, possibly also during earlier and later months. The term was coined in reports from the UNEP Indian Ocean Experiment. Global dimming creates a cooling effect that reduces the global average temperature by something in the order of 0.3 to 0.7 degrees centigrade. Globally, it should be more like 1816. In that year, this country recorded its lowest ever July temperature. In the aftermath of the 9/11 attacks in the United States, all commercial aircraft were grounded for at least 3 days. During that time, scientists were able to test the extent to which global dimming was taking place. They found global dimming was taking place. To better understand why the Earth is not getting colder, we need to look at how all of this works. Scientists have long known that the presence of an atmosphere keeps the surface of the planet warmer than it would be without an atmosphere. In fact, without an atmosphere, the surface of the Earth would be about 30 degrees cooler than it is now. We know that the Earth emits enough long-wave radiation into space to equal the solar radiation absorbed by it. This is known as the radiative equilibrium. This maintains the Earth at a constant temperature. Think of an electric fire heating a big, cold room. Eventually, the heat lost by the room will be equal to the energy supplied by the fire. The room will get to a certain temperature, but won't get any warmer. In order to understand why this is the case, we need to consider the surface of the Earth and the atmosphere separately. Shortwave radiation from the Sun hits the atmosphere. Most of it passes straight through and hits the surface of the Earth. However, some of this shortwave radiation is reflected directly off the atmosphere. Most of the long-wave radiation that is emitted by the planet into space is emitted by the atmosphere rather than the surface of the Earth beneath it. Although the surface of the Earth does emit long-wave radiation, only about 10% of this radiation passes through the atmosphere. The rest is absorbed by clouds and greenhouse gases in the atmosphere. There are many greenhouse gases, but the most abundant greenhouse gases are water vapor and carbon dioxide. Short-wave radiation from the Sun passes through greenhouse gases, but long-wave radiation is absorbed by them. Greenhouse gases absorb long-wave radiation that is emitted by the surface of the Earth. They then re-emit the energy as long-wave radiation in all directions. About half of the re-emitted long-wave radiation does escape into space and contributes to the radiative equilibrium. About half of the long-wave radiation emitted by the gases is directed back towards the surface of the Earth. As a result, a continual exchange of long-wave radiation takes place between the surface of the Earth and the atmosphere above it. The long-wave radiation contained in this exchange causes the greenhouse effect. The phenomenon is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water vapor and carbon dioxide allow solar energy to penetrate Earth's atmosphere, but prevent much of the long-wave radiation emitted by the surface of the Earth from escaping into space. This trapping of long-wave energy is called the greenhouse effect and enhances the surface temperatures of the Earth. When pollutants like soot and sulfur from volcanic eruptions get into the atmosphere, less global radiation reaches the Earth. More radiation is reflected directly from the atmosphere and the Earth becomes cooler. So why is it getting hotter? This is Australia at the beginning of this year. Australia experienced record temperatures and bushfires raging out of control. In some parts of Australia, this was followed by flooding and then snow. So clearly there are factors other than global dimming and the greenhouse effect involved. What are they? Well, that's coming next. Just a quick reminder, in case you didn't know. It will soon be the end of the school year. We will soon be coming to the end of this ecology topic, and you have a test coming up. Why not do a bit of revision? There are all our films to watch and quizzes to test yourself.